Okay, so this video is going to be about your energy transform lab. Okay, this is going to be a summative grade. You're going to be doing a lab write-up. So today's objective is to gather the data that you're going to need to complete this lab. Okay, so today is just getting the data. The next video will be on the lab write-up portion. Okay, so let's go ahead and look at this. So here's your energy transformations lab. It gives you kind of a overview of what's going on, purpose, and the procedure. Okay. So the key here is this. When you read the procedure, the key is you're going to determine the relationship between mass and velocity, the spring constant and velocity, and you're going to relationship between spring compression and velocity. Okay, so there's three different things. So in this case, you're going to have three different independent variables, and you're going to see how and what effect they have on the dependent variable, which in this case is going to be velocity. Okay, so just remember that we're going to be looking at mass. So we're going to be changing mass, we're going to be changing the spring constant K, and we're going to be changing the distance the spring is compressed, delta X. These three, and we're going to see how these three affect the velocity of an object. Okay, so that's the objective of the lab. Let me go ahead and show you the lab right here. So you can follow that link. Hopefully I didn't do that too fast. So in here, in the procedure, it has the link. So you click there and you click there, click begin. All right. So some things here. Okay. It gives you a distance. It gives you 18 meters. Okay. Between blue line to blue line. So with that, you're going to be able to calculate the velocity here. Okay. And how you're going to do that is this. You're going to, so once you set Trevor, so set this guy, let's just show you what happens. So I set him, I put him back, I fire him. He's going to be moving. And because he's on ice, he's moving at a constant speed, right? So what they're saying is because he's on ice, there's no friction. So it's a closed, isolated system. Okay. And he's going to be moving at a constant speed. So I know for velocity, what I could do to calculate velocity, I'm going to use this delta x over time. And I know my delta x here that I'm using is going to be 18. So for each one, you're going to do 18 meters. So if I was to do this, just showing you how to calculate velocity. I'm not talking about the lab yet or anything like that. So I'm going to set them to whatever, pull them back, and I fire them. I would have my timer, and I would start the timer when he gets to the first blue line. So start, and then stop him when he gets to the next blue line. Stop. And now I know my time was 4.12. And I could calculate a velocity there. So I would, if I was doing a trial like this, I'd do 18 divided by 4.2, and I would get, his velocity would be 4.3 meters per second. All right. Now, I was just showing you how you're going to get velocity. Now, let me talk about the actual lab and the setup. So remember, we're changing three things here. We're changing mass, we're changing spring constant, and we're changing delta x. In other words, how far I compress the spring. So when you're changing one of them, you have to keep the other two constants. So the only thing that's changing is that thing. So you're actually going to have three data tables here. So for my mass, so I would write this in my data section. I have a mass versus velocity data table. And what I would make is I would make a column that says mass. All right. You're going to need 10 different things here. So 1 through 10, you're going to have 10 different masses. Okay. And then I would have, you could record your times. Oh, that's a V. You could record your times, and then you could calculate your velocities. Okay. You also have to note, all right, once I do this, so if I'm going to give you an example here, I'm going to start doing this. So I'm going to start with my mass at 75. So I would write 75. All right. I want to note, you're not going to write this in your chart, but notes somewhere like maybe above the data table, I would say I'm always going to keep the spring constant as, so K will always equal 1,000. And my distance will always equal, so when I set Trevor, I'll always set it to be 2 meters. Just you can do whatever you want, but watch, I always show 2 meters. I always keep these two the same. I just have to note that's what I'm keeping the same. So now when I fire him, I gotta get ready to start the timer. So start, stop, 2.46. So I'd write in my data table 2.46. So time is 2.46. Now I don't change K or the compression. What I change here is I change my mass. So I'll just go up by 10. So I'd change it here by 10. So I would go 85. And you would do the same thing. I don't change spring constant. I leave it as 1,000. So I go to set Trevor again. All right, I got to set my man. I had him to 2 meters, so I got to put him all the way back to 2 meters, right? The edge of the spring went from 0 to 2 meters, so I know that's my displacement. So if I fire Trevor here, again, I'm going to hit start, and I'm going to hit stop. So I got 2.64 seconds. So in my table, I write 2.64. Now you're going to do the same thing 10 different times. And this is how, see how we're only changing mass. And then what you do is you calculate your velocity using this equation that I showed you before. That's what I was talking about here, where your delta x is 18 meters. And that's how you're going to get this column in velocity. So as you can see, we're looking at how the mass changing is going to affect the velocity. Okay? So that's one of your data tables done. Now let's go to the next one. Let's look at the next one here. So if I erase all this, all right. So the next one I want to do is my K value. So my K value, okay? So to do my K value, I'm going to set it up like this. Spring constant versus velocity. Again, now I'm keeping my mass the same. So I'll say my mass, I'm always going to keep at 85. And my delta x, I'll still keep at 2 meters, right? Because I know my compression is going to stay the same. So now my chart should look like this. Spring constant, time, velocity. You're going to do 10 different ones. So I'm going to start at 1,000. So I'm leaving my mass at 85 because that's staying the same. And then when I go here, I set Trevor again. I pull him back to 2 meters. It's 2 meters. I fire Trevor. I'll do it here. So I have to start it. So pop, pop. Oh, I missed the button. So I remember it was, so I didn't change anything. I remember it was 2.46. So sorry, I missed the button. So 1,000 gives me 2.46. I think I remember from the last one because I didn't change anything yet. So now instead of changing your mass, let's increase our spring constant and we'll do it by 100. So now I have 1,100 here. So now I write my spring constant 1,100. Okay, I'm going to set them again. So the only thing I'm changing is the spring constant. I have to pull them back to 2 meters, which is here. I fire Trevor. Start. Stop. It seemed like it was messed up. Let me do that again. Let me do that one more time. Sorry. Fire. Oh, I'm sorry. Sorry, I had a brain. 2 meters. Fire. I was expecting the timer to start automatically. Start. Stop. All right, that shouldn't be right. So it's 2.46. Hold on, let me work this out here. 2.46. So I got to redo this one. I messed up on that one. So let me go back. Let me go back on the data. That's my bad. Said Trevor, 2 meters. Fire. Yeah, 2.68. That's the first one was that. Sorry. 2.68. All right. Hopefully you get the drift here. I just kept messing up with my data. So now instead of 1,100, I do 1,200. And I can set them again, and I'm going to set them to 2 meters. Fire. Start. Stop. 2.36. And you would do that for 10 different spring constants. Okay, so 10 different spring constants. So now the same thing, you can calculate your velocity using this. So same way, you know, 18 is always going to be the same because you time it from blue line to blue line. And then you can get your velocity there. Okay, so that's the second one. Now the third and final one, so let's erase this. And for each section, you're doing 10 different trials, 10 different setups. So now I'm changing my displacement I. So now what I'm changing is how far I compress. So my delta x versus velocity. So now I'm going to keep my mass constant, 85, and I'm going to keep my spring constant, which is 1,200. And I'm going to have delta x, I'm going to have time, and I'm going to have velocity. And I'm going to do 1 through 10 different things here. All right. So now I'm going to set this. So let's set Trevor, and I'm going to set them real small. So let me, wait, I got all these lines here. Let me erase this. All right. I'm going to set it real small. I'll pull it back 0.2, and I'll fire Trevor. Okay. Absolutely not. I will, let's reset that because that's going to take 10 years. So I'll start at 1. Fire. So I fired at 1. I hit start. I hit stop. So I got my delta x was 1. My time was 4.82. All right. So now I have to reset. So I set Trevor again, and I'll go 1.2 meters. So now I do 1.2. I fire. Start. Stop. 4. So I got 4.08. And you would keep doing the same thing for 10 more trials. Once you get all of that data, that's exactly what you want to do. Then you're going to be making graphs. So I recommend typing your data into Excel because you're going to be making graphs. And let's think about this, okay? What did I say was our dependent variables? Well, our dependent variables, okay, were our mass, our spring constant, and our delta x, okay? So what we will do is that will be, these will be, so we're going to have 3 graphs. We're going to have, and like I said, so on the first graph, you're going to have mass down here. On the second graph, you're going to have K down here. On the third graph, you're going to have delta X down there. And all 3 graphs, what changed? What was our dependent variable? Well, our dependent variable was velocity. Velocity, velocity. Okay, so enter those values in. You're going to graph from your data charts, just like we do a scatter plot, and then look at the relationship between that. So what I need you to do today is get your data done and typed into Excel and see if you can make the charts, see if you can make the graphs. If not, when I do the next class, we will analyze data together and go from there. All right, good luck.